Good morning, everybody. Thanks for having me over. Thanks, Andre, for inviting me. A year ago, we met at an event, and he got me excited to come over and visit the wonderful people here at Estonia. Now I know why he did so, and I'm so happy that I was able to travel here and have a chance to talk to you. So, following on the minister's story on childbirth, to me, it takes a different kind of metaphorical meaning when it comes to machine intelligence. Because neural networks is nothing new. It's been there for a long period. It's just that we haven't been able to train this baby well enough to do things that we would like them to do, or have their own minds eventually, maybe. So, in the past few years, maybe about a decade or so, several innovations have gone in, which makes these things, the baby steps possible. So the moment the baby is born, they're able to see things. Obviously, if we were to tap into their head, we would be able to see exactly what they were seeing. Unfortunately, we can't. Okay. So at Allen Institute, I was able to tap into mice brains and able to see how they evolve. Okay. So many of the evolutionary framework are either naturally or somewhat coincidentally being observed in these neural nets that we talk about today. These primitive features that we talk about, like seeing edges, contrast, different colors, are integral to these machinery that learn themselves. Unfortunately, I don't have time today to walk you through all the interesting stuff that goes on there, but today what I'll give you is a whirlwind spin of all the places where scalable deep learning is occurring and how it's kind of increasingly getting into our day-to-day lives. You'll see a lot of slides here, so don't try to memorize them. They'll be distributed to you. It's more for you to go back and refer to the parts that interest you. So initial part of my talk is going to be largely on giving you a feel of where machine learning is being seen. Many of you are probably comfortable with that. And then the second half of the talk, I'm going to go a little bit deeper into deep learning, how it is evolving, what are some of the tools that may be available to you, and how you could contribute in growing this baby to take steps so that when I'm driving the car 5 years from now, that a pedestrian is not confused with the road. Okay, I don't want to be the driver or the pedestrian. So, but we have a role to play to make that happen. It just won't happen on its own. All right? So with that, deep learning at Microsoft is pervasive everywhere. Microsoft Cognitive Services, looks like the pointer is not showing up here on the screen. Oh, it does, but it's very faint. Anyway, so the Microsoft Cognitive Services is a set of APIs that you can today tap in to do various tasks associated with speech, text, image, related vision. For those of you who want to get started and are not quite savvy enough or willing to go ahead and train or create your own machines, so you can take vast array of technologies that is available and leverage to getting your product started. This is particularly relevant for startups, where that knowledge, expertise, the computational horsepower and the data may not be adequately available. Skype, I would like to mention thank you for Estonia and the engineers at Tallinn to bring Skype to the world. I use it every day, multiple hours, for a variety of different things. My family uses it. My kids use it for doing school homework with their peers, interacting with integrated AI within Office suite of software portfolios. And thank you for that. Cortana is speech-related APIs and technologies where you interact with the system. As I speak, you would be able to see what I'm speaking in a transcribed way. I'm going to give you a brief look into what it means. But these are areas where deep learning and scalable deep learning, you'll become familiar what scalable means shortly. Bing, like Google, is a web search platform and has an advertisement platform tied to it. Without machine learning, deep learning, and at petabyte scale, it's impossible to do what we do today. Okay. HoloLens. How many of you have heard about HoloLens? Quite a few. It has many opportunities for application scenarios that you can contribute to today, where you can augmented reality, where you can augment the setup that I have here, and maybe as I look to each of you, I could think about, I could see what your faces are, and maybe if you have shared a public profile, I would know your interests, so that I could fine-tune my talk as I go along, so that it tailors to your interest as I'm speaking. This technology and many others are being exposed through these platforms like HoloLens, and many of you have already played with Xbox, I assume, like I do, and it has a lot of AI components built into it. Doesn't happen just by itself. There's a suite of applications that show that how AI grows. How-old.net, if you haven't played with it, I suggest that you play with it. When it initially came out, it was not very good at predicting the ages of the individuals in the pictures. But eventually, now if you do it, it will come pretty close to what your reality, your real age is. And the idea is these machines learn. As you interact, you exchange data, you send signals about whether the machine was correct or not. It automatically learns from that and grows, just like a child. Just like a child, where we they do take some steps, they make mistakes, they correct themselves, and they move on. The only difference today with the machines is we have to show a lot of examples to make the machines work. As opposed to a child, like my kids, they'll test the hot surface of the electrical circuit only once, and they know that not to do it again. Okay, that's the difference. We have to get there, but it will happen eventually. But these machines not only do simple classification and regression. Here you can see that a picture is given, and the one in the middle, and it generates an automatic description of the text in textual pattern. So this is available to you in Office 2016 if you are using it, and it's very important for situations where you want to build applications for visually challenged people who cannot see the pictures properly. You have to generate some content, and you want to tag them automatically. Saves you a lot of time. I've done that myself. It's called alt text, for those of you who don't know. And you can, if you populate it properly, using a reader, a visually challenged person can easily see it. Microsoft works with a lot of partners and startups. One of them is this refrigerator company. They are building technologies to bring intelligence into the refrigerator by doing automatic detection of objects, classifying them, although my refrigerator doesn't look that clean ever, except barring once or twice a year. Here's an example of where in healthcare AI is becoming increasingly pervasive.
In China, there are 100 million people with diabetes. Diabetic retinopathy, or DR, is one of the most common complications of diabetes. Patients will go blind without proper treatment.
AdDoc DR is very useful and very easy to use. Just upload the photos and it will give the diagnosis.
We leverage our deep learning technologies on Azure with a set of open source tools like Linux and Python. Training deep learning models in Azure is very easy.
With support of distributed training feature in cognitive toolkits, we can shorten the training time so we can iterate our algorithm quickly.
Azure provides N24 servers, which is GPU server we use a lot. Azure commercially availability ensures our data security as well as our mission critical service level to our customers. Every day is a great day because we are saving people's lives.
This is another partner. They had a technology that was not performing very well in being able to do price matches for these individual pictures. They used deep learning technologies, and within 2 days, they were able to build a very efficient technology that scales very well using the Azure GPU platform and do very accurate price prediction on these diverse range of clothing, which it's almost impossible to do, or it's possible to do, but you get large error rates using just text-based descriptions of these pictures. Bing Ads has built-in lot of intelligence. For instance, this query, most sold fruit in US, automatically maps fruits into bananas, apples, grapes, and strawberries and others. It's automatically learned. That's the key thing. There's nobody who taught this machine that fruit is equal to blah. And it's not a fruit classifier, because then we'll be running all billions of classifiers for everything. It's not possible to do. So train a large machine that's able to do that. Don't have time to talk about Bing ads, but again, here the thing is the ad inventory keeps changing very frequently before Christmas, because Thanksgiving advertisers bring in a lot of content and take them out once it is done. So that means data changes a lot, and you'll hear a little bit about that later on in this conference, how to deal with that. It's important to recognize that these machines require a lot of compute, the data can change, and you have to adapt to it. In speech, there are several breakthrough records that the company has brought to bear, and we are at a stage where we are able to do on par or better than the human recognition of speech. Many of you may not be able to recognize my accent, but are able to do it with certain level of degree of accuracy. As long as we can communicate with one another, we should be pretty good to go. However, if I had a translator, maybe you could hear me speak in Estonian. And it's not too far away. There are many languages that are supported by the translate.it. You can install that on your phone through an app, and as I speak, you can listen or see what I'm talking in your native language. I don't know whether Estonian is covered or not, but there are many other languages and many other that is supported, and many others that we are working on. As you go along, these technologies are finding its way into different products, like PowerPoint has automatic captioning, where you can find, as you speak, the transcription will appear automatically on the slides, so people in the audience can follow in their own, in a language that they can visually see, instead of relying on audio bites that are coming out of my mouth. Being in Estonia, I thought I would put this video. I'm not going to go through it completely. It's a translator app where in Skype you talk in one language and the person on the other side can listen to what was spoken in another language.
Könnten Sie das Grün durch einen helleren Farbton ändern?
Ja, wir können das Grün viel heller machen.
Yes, we can make the green much brighter.
Ich sende die Autogramm.
For the sake of time, I'm going to move forward, but you'll get the link to the video if you want to watch. And thank you, Estonia, for delivering such wonderful products that makes a big difference in our lives. Recently, Huawei was a very popular phone carrier in Asia, and the phones are very, very slick. They have started using the translator as an integrated app within their phones. And if you are thinking of startups and ideas where you have language-related challenges that you want to solve, these might be technologies that you can build on top of. Customer support agent increasingly is shifting into AI-based technologies. It's using recurrent networks, using reinforcement learning techniques. An agent virtual agent can automatically interact with the user who is speaking here that I am having trouble setting up my projector with my laptop, and the agent gives suggestions and seeks feedback, and based on the feedback, there's a reinforcement learning algorithm that goes behind the scenes and is able to suggest corrections or alternatives. And should they not be able to solve the problem, they can quickly go and recruit an expert from the field. So this leads to a huge amount of customer satisfaction and savings in terms of what is needed to support these call center queries that come all the time. For many of you who are new to deep learning, it's not hard to learn these things. It's pretty straightforward machinery. There are a lot of options. There's a course that I offer online that you can take for free if you are uninitiated or want to know a lot more nuanced versions and details that I am not able to cover in this speech here today. So one of the things you may have gone into where people are running into, for those of you who are already familiar with deep learning, are the plethora of toolkits that is available to you. So you could have CNTK, TensorFlow, Caffe, Torch. These are different kinds of toolkits that are available to you. And the challenges is optimizations layer have to operate on all frameworks and hardware combinations. So these toolkits have to, that you use to build the software has to run on different kinds of hardwares for different kinds of OSs. How can you make it work? It's not easy to translate from one framework platform to another one. And there's increasing fragmentation across teams. Even within Microsoft, which is a giant company, we use all these different kinds of frameworks within the company. And you can, depending on your stack that you want to solve the problem, you choose a combination of these gray, black, and blue boxes. And the idea is that how can you unify these things so that the team fragmentation is not as aggressive. So an intermediate representation is an obvious solution. So online neural net exchange is one of the new formats. It's called Onyx. I encourage you to take a look at it. It's born in collaboration with Facebook and Microsoft out of this need appearing to homogenize the stack, where you could use a toolkit to do a certain thing and use another toolkit to do another thing. But at the end, you want to solve for a different use case. The thing that you want to do is from research, training, to development and deployment, you want to use maximally leverage all these different kinds of tools that are available to you to most expeditiously get your content out in the form of a product. So you can see a wide range of partners are working on this framework that's evolving. It's great to see the community come together and build this ecosystem. So the strategy is to drive AI and apps and models to be built and run on Microsoft platforms. From Microsoft perspective, if you have your own company, it would be how you want to deliver them. From Microsoft perspective, the key word here is to support any popular network. And we focus on training technologies and very fundamental technologies to solve hard problems like RNN and 1-bit SGD. If I have time, I'll go into details today. But you have the content from the slide and you can go back and look it up on the net. And the idea is that we provide this IP to the community to build solutions. And then the Onyx standard would be like enable you to work in partnerships with the industry and use different kinds of deep learned or machine learned models to interoperate between different technologies that you have access to today. So Onyx is an open source intermediate representation of a computational graph, and which has common operators and semantics, collaboration with Microsoft and Facebook that it's all started. It's like a whole lot of partners are now joining, as you saw. And again, it's MIT licensed, so no patents involved. So this is really what's driving the AI field into the, for common people, for large people who don't have access to resources or data or technologies or software know-how to expeditiously leverage. And I strongly encourage the huge startup culture that I see here to leverage that opportunity. So here is, in a nutshell, what the framework looks like, where you have language bindings on the top layer, and then you have a range of toolkits that you can choose from. You target the backend that you want to use for training or evaluation using Open Neural Net Exchange, and then you can have the CPU, GPU, FPGA, whatever core hardware that you want to operate on. So it would unify all the components that is available in open source, the disparate ones, and bring them together. So for hardware vendor, it's important that while we enable interoperability from a research perspective and development perspective, for hardware vendors, it's important to focus on the intermediate representation in the backend optimization. And for flexibility for the researcher, you want to train on your preferred network and deploy on another framework without friction. And given these are all open source, it should break all the barriers for you to expeditiously build different use cases that, as you individually see them, you want to open companies and bring your own business solutions along with it, it should be a very, it would even level out the field and get you things, get your problem going faster. So I'm going to talk a little bit about the cognitive toolkit that I work on extensively, and I continue to use it. And it's available as a part of the Open Neural Net Exchange that you have. And one of the reasons I use it is because it's fast, it's flexible, and it's very, very scalable. And supported in Python, C++, and in C# for those of you who are using .NET development platform for both training and inference. Universal Windows platform support is there. And for many of you who may not be aware, this fast binarized evaluation, where instead of having a full precision network, you can make the network weights to be binary, like zeros and ones, and like ones and ones, and achieve significant speed up. If I have time, I'll show you a quick video later on. So the toolkit provides low-level APIs, which offers flexibility. It has layers APIs similar to some of the other toolkits that you might see, which would bring down the barriers similar to Keras that you might be familiar with, and very much like Keras, except it's a little bit Keras on steroids. You might think about it, that enables you to write very compact code. The distributed framework is one of the easiest one I have come across. I'm biased maybe, but yeah, it is one of the easiest ones. With little less than 5-6 lines of code, you can turn your single GPU training into supporting multiple GPUs. As I speak, I'm training a model on 64 GPUs. All I had to do was MPI exec -n and put the number 64, and then the IP addresses for those machines with the GPUs on it. And that's about it, what I needed to do to get my model training on 64 instead of 1. The good thing is that as I use multiple GPUs, I can get them faster. By the time I get home, the results will be ready. These models are big. They work on terabytes of data. It takes a while to train. So having multiple GPUs is critical. The other thing to make it work is scalable readers. Increasingly, that is becoming available to you. The CNTK toolkit initially was one of the first ones to provide these readers, because as a data scientist, as a machine learning scientist, you probably spend a significant chunk of your time just managing the data, just reading it in properly, just dealing with all the outliers, missing fields, and whatnot to feed into your training machine. The modeling part of it is pretty straightforward. Usually it doesn't take me more than 30 minutes to write up the modeling code. It's just that writing the rest of the code, the glue code, makes it harder. Okay? So I'm going to skip this one because I've already talked about it. So one of the things that make it faster are some of the innovations coming from Microsoft Research, which is 1-bit SGD. I'm going to talk briefly about it later on, and block momentum, which reduces the frequency of communication. I'm going to talk a little bit about it later on. We use state-of-the-art technologies from NVIDIA. We work very closely with them, with Nickel 2, and on the Volta machines you can use fixed point 16 arithmetic. And then I talked a little bit about binarized evaluation. Here is an example of what binarized evaluation would look for ConvNet. Let me see. So you can see on the left frame. So you can see the frame rates on the left-hand side versus on the right-hand side. One is without binarization versus with binarization on a CPU. Okay, so the same model that has been binarized can run so much better and with equal accuracy without any compromise, using these efficient binarization techniques that are available to these toolkits. Huge benefit for our end users, and you can have different kinds of applications that benefit from that, including applications where power utilization is a big concern. Some of the top line is interesting. We use the neuroartistic rendering for rendering NVIDIA CEO into Picasso-style painting. You can generate your own. This is it's a tutorial available in CNTK. You can have fun with it, or if you have kids who are interested, you want them to get interested, you can let them play with it. And one of the reasons NVIDIA chooses our platform to be on the DGX machine is because of the significant performance and scalability that we bring to bear. So let's take a closer look. I don't have much time. I'll go through it relatively fast. But the idea is that CNTK allows you to compose arbitrary networks into complex computational networks. So if you have a feed-forward network like I've shown here, which has two hidden layers, H1 and H2, and the output layer is a softmax, you can turn it into a graph. And most of these engines do that. Internally, you can see those. I am unable to point it out. Otherwise, you would see those round circly things are the nodes that has operators, and the ones that with the arrows are the parameters. So effectively, you build a graph from the code that you see on the right-hand side. And the nodes are composed of reusable composites. These are operands that you can build and build your network together. And the edge values are the tensors. They can be dense or sparse. And most of these networks have automatic differentiation built into it. And you kind of let the engine optimize the workflow. Internally, you do a lot of different tricks to make things go faster. I'm going to talk about one such trick in a bit. But if you want to learn more about it, please go and take a look at my course that I was alluding to get a better feel of what I'm talking. I'm going a little bit speedily at this point of time. For those of you who are familiar with deep networks or the frameworks, this should be pretty straightforward. And you can then edit these models, clone them, replace parts of it, and fine-tune to your own applications. And it's fairly straightforward. There's tutorials available in the toolkit that let you do that. So it allows you to have Lego-like composability for different applications. So let's take a closer look at a couple of things. We'll talk about symbolic loops, we'll talk about batch scheduling, and we'll talk about data parallel training. So if you wanted to extend your recurrent networks to recurrent networks, what you need to do is build in a sense of time. So if you notice that in the previous slides, I had everything in place except the fact that there's a past value of H1 and past value of H2 that has been added to this two-layer deep network, right? It's a trivial example. But the idea is that this toolkit is designed, originally came from speech community. So it's automatically geared up to deal with cycles in the graph. And with adding constructs like past value, it's able to build a context where what was the word that is preceding my current word? So if I want to do buy flights to York versus New York, makes a vast difference because York is a city in UK and the other one is in US, right? So having that context of new ahead of the word York makes a huge difference, and you can easily model that with the past value declaration that you see over there on the screen. So there's no explicit notion of time that you need to build in. This is unique to this toolkit, and because of this, you will notice that these networks run very, very speedily in this toolkit. You're talking about 5 to 10 times performance difference compared to other toolkits when it comes to recurrent networks. Thank you. So as simple as adding the past value, and in terms of symbolic representation, it's a time step in past. So if you want to model what's the next word, based on the next word I can predict things better, you can just add a construct called future value. Another thing that makes it really, really fast is this notion of dealing with variable length sequences. Now, as I speak a sentence, I'm not always speaking the same number of words, or the time taken by me is also different. So when you're modeling these things, the sequences appear in different lengths. Typically, you would do padding, or you'll batch sequences of similar lengths while training a network. Whenever you do that, you break randomization. So your performance of your network, what it potentially could have, is already compromised because you've broken randomness that is needed for training these complex networks. So what we do internally you don't have to do this. You see that as if you are feeding these networks of arbitrary lengths, but you pretend that they are homogeneous. Internally, we rearrange the data so that you only do a very little bit of padding, and inside we take care of all the sequences being rearranged in memory, and we process only those chunks of the memory segments. You can see that this is much more compact. We waste less in terms of memory, and also the fact that we don't break randomization. There's a lot of bookkeeping that goes on to do with it, so if you want to do it yourself, it might take you for a long, long time, unless your framework is designed ground up to deal with this kind of variable length sequences. I'm going rather fast, so this is in itself takes 30 minutes to explain. So if you're confused, I don't blame you. Please get hold of me after the talk and I'll explain to you more. Last thing I want to talk about is the data parallel training. So parallelism is key, as I said, to be able to leverage multiple GPUs to get jobs done in a realistic time scale. This is what would happen if all these node 1, node 2, node 3, which work on their respective chunks of training data, and you want to aggregate them after each iteration, each worker node, the node 1, node 2, node 3, finishes their training. And if you wanted to reduce or sum all the gradients from these workers, which you need to do for your back propagation, then this master node becomes a choke point. So one of the ways to avoid that is using this ring algorithm, and with order 1 with respect to the number of nodes here k, you can do the distributed computing and aggregation of weights in a more efficient manner. However, those bold lines that you see, those are the weights that needs to be communicated across processors. So that becomes a bottleneck. So even for a small DNN with 160 million parameters, you can see that the GPU overhead, the communication between the GPUs can become bottleneck. So what you can do is do two things. One is communicate less each time. That means instead of communicating 32-bit floating points for each update across the servers, you can just do 1 bit. Okay, 1 bit, yeah. And this paper actually talks about how using 1 bit instead of 32-bit leads to no loss in accuracy. No loss in accuracy. Okay, and it's theoretically proven and practically made available to you through this toolkit that lets you do the aggregation with 1 bit and makes things enormously faster, because now you're, instead of 32-bit, you're communicating 1 bit. Okay, and the trick is to carry quantization error. So every step, whenever you quantize a 32-bit into 1 bit, there's an error. So you don't drop the error on the floor. You just carry it over in the same worker, and you keep aggregating it across multiple iterations, and that leads to this kind of very interesting behavior and optimization that is made available to you to leverage from this toolkit, in this toolkit. And then the other thing is communicate less often. So automatic many-bit sizing is one of them. The other one, more recent one, is called block momentum. It's a very effective parallelization method, and the idea is that you divide the data into blocks and do not move the data across blocks as much. So combines the idea of model averaging, which operates on blocks of data, in hand in hand with the 1-bit SGD approach. Finally, the toolkits allows you to do customization. So you can now add your own custom layer with your Python. You can define your own operands. You can have a forward. What you need to provide is a initialization. You have to provide a forward method. That is your custom function, and then you have to provide the backward pass for the back propagation to work. You have to provide the backward function, and then the shapes, because you have input and outputs defined. The network can infer what the shapes of that individual node has to be from the inputs and the outputs that are defined by you. You can define your custom learners. So if you want to have your own learner, sure. bring it along. Along those lines, there are, the toolkit provides you with a lot of examples, tutorials that help you deal with these kind of custom data that you may be having, and working with sequences, because we deal sequences very differently than other toolkits. I would seriously encourage you to try out some of the tutorials. Particularly in the tutorial section, there's a tutorial called CNTK 202 for you to get a proper feeling of these dynamic length sequences that I just talked about. Unless you do it yourself as a hands-on exercise, for those of you who really want to get your hands dirty, you won't get a good feel for that, what I just talked about. And as you go on, for the developers here, please refer to the manuals. And this is one of our efforts to capture all the questions that we get from you and others in the community and turn them into practical recipes. And these are Jupyter notebooks that are compiled and tested every night. And you can run them, you can see, I'm sure you'll need one tutorial if you are using this toolkit, is how to debug CNTK Python programs. That's something very fundamental to development process. We have a lot of guidelines that we have suggested for developers to go through. Then you have the other popular thing is, how am I going to read this data? How am I going to read that data? How can I combine my audio data with my video data and or speech data or text data? All of that is available through how to read and feed data, and then you can then go into learners, how to design your own optimizers. And if you need to, we have a wide variety of optimizers for you, so I would not suggest you start doing the learners part right away on your own. Try out the ones that come out of the box, and then you can have how to create custom deserializers. So for those, and this is something needed a lot of time, because you would have different data types and you may want to serialize and deserialize the data in different ways that you want to leverage this toolkit for. And more information is available at cntk.ai, and please take a closer look at onyx.ai, which is relatively new. We are looking for contributions from the community, and the more the community participates, the AI ecosystem that I just talked about will grow better. It will break down the barrier. It will democratize the AI tools and resources that are available for all of us, and help this child grow up into the next stage where, you know, I don't have to show them 10,000 different examples of hot and cold to make the machine learn. Rather, do it like one-shot learning, where we provide fewer examples and we are able to do that. And the other part would be that, which is often ignored by most, but it's an open area for research and innovation, is how to do this computation in a power efficient manner. Our brain don't get hot as much, nearly as much. We'll be cooked alive if you touch a GPU doing a simple training today. So the amount of energy we spend in doing these computations are humongous. So we really need to figure out how to make it more efficient. So with that, I'll close my talk and take questions from the audience.
More than 20 questions from our great audience.
Great.
And I will choose the 3 or maybe 4 most popular ones. So, does Translate IT use any speech corpora database to train the machine? How it's possible to translate distinct languages in real time and high accuracy?
That's a big question, and it requires a lot of explanation. These machines require a lot of data. So it's important for you to have that data. In fact, I gave a talk yesterday, and the same question got asked. So I'm going to give you a shorter version. Please get hold of me after the talk, and I can give you more ideas. So if you have language A and language B, and you can train a network fully, that requires a lot of data. Now, if you have a language B, say Finnish, for which you have English to Finnish translator, then you can use that as the starting model and train an Estonian model on top of it. I didn't know this similarity yesterday. Somebody explained to me, so thank you for whoever did that yesterday, because I didn't know which was the closest language to Estonian, and it's finished. So that would be one way to do it. The other way is translative, what you call a transitive closure, where if you have a translator from A to B and another one from B to C, then you can build one from A to C. And regarding scalability, that's a story in itself. Please get hold of me, whoever asked that outside of this.
And with all other questions I'm not able to ask here. So the second question, Daivo is asking, what are some of the best investment of time and money that you or your team have recently made in the field of machine learning?
Oh, this field grows so fast. Before these slides become obsolete in a week or 2 weeks. So many things goes on in this community. It's very hard to keep up. So for me, I'm a faculty and I have an army of students, and it's very important to engage with young, enthusiastic people who are doing different things and have meetups like this, where you can convert and learn things from the community quickly, frequently. The second thing is on good hardware. Super important to be able to leverage these hardwares in combinations with software. If you could not train these models fast enough, then somebody would have done it, and you would have been left wondering like why you couldn't make it work. So investing on good machines, investing on having access to a cloud infrastructure that lets you scale up your training is super important.
Thank you. And how does Microsoft share the knowledge and experience with competitors like Google and with public community?
So as you can see, all of this that I talked about is open source. It's available through Linux and Windows operating systems. You saw the Open Neural Net Exchange is a complete effort to bring all the competitors together, because the problem area is vast and there's no shortage of opportunities. The more we can cross-leverage each other's, we are better off. So the world is changing, and there was an article a few days ago how machine learning is making competitive enemies as friends, or something like foes as friends, something of that effect. It was a business article, but it shows that how the open source culture is bringing all the disparate business entities as well as hardware manufacturers together.
Okay, and we have time to take one more question. Can you touch upon Microsoft's most successful product in the last 5 years by new users, chatbot Shios? What's the future of it?
So chatbot is a very interesting evolution of AI systems. As you can see, I alluded to the customer service experience. Think about the chatbots being similar to that. So Microsoft is hugely able to capitalize on such technologies at an enterprise scale. We specialize in being able to deal with enterprise data. What it means is that your data is yours and it's kept limited to yours. Learning from your data and giving it to another company is something that is not what we do in terms of when it comes to enterprise. When it comes to your public data, like when you are browsing the web or web searching or using an app, you sign off your data for the use. Say the location services are hugely commoditized today by different kinds of companies, and you have given rights to that. When it comes to enterprise, you cannot do that. So these chatbots have to be applied in the context of where you're going to deploy it. Is it going to be a public domain app for consumers, or is it going to be for enterprise? If it's going to be enterprise, I don't even get to see what the data is when I'm training the models. So without seeing data, how do you train these AI models? That's an art in itself. We can talk about that later. But first you have to dissociate whom this application is going to go for, what scenario. You have access to data. If you do, that's one way. If you don't, it's a completely different ballgame. So it's no straight answers, but applications like Shawise are finding its way in both community, in consumers, and as well as a vast majority of enterprise applications. I always say this: how many of you would know that a product that got built used Visual Studio as their underlying IDE for development, or VS Code for that matter of fact. You don't. So there are a lot of places where Microsoft has played which you don't even get to see because it's at an enterprise level, and enterprise uses a ton of technology that comes from Microsoft today. And then they white label it and build on top of it and take it out to the consumers as their own.
Thank you.
Thank you.